Okay, so this video we're going to be solving by completing the square and using square roots. Okay, so solve each equation by finding the square roots. So if I was just solving this, first I would divide by 5, because we're trying to get x by itself. 80 divided by 5 is 16. The opposite of squaring is square rooting. Square root of 16 is 4, but whenever we're solving, remember there's always a plus side and a minus side, because an x squared graph should have two spots where it could potentially be crossing the x-axis, so that means we need to include the positive side of it and the negative side of it if we were to graph that. Okay, this one, if I were to solve it, I could add 4 to get x squared equals 4, square root both sides, so x is equal to plus or minus 2. This one I could add 40. 5x squared equals 40. I need to get rid of the things attached to that x squared before I square root, otherwise we're not going to be square rooting the right thing. So 40 divided by 5 is going to be 8. When we square root that, I get x equals plus or minus, and then in your calculator it might easily give you the square root of 8. If I were to break it down, two things that multiply to get me 8 is the square root of 4 and the square root of 2. Well, the square root of 4 is just 2. So simplified, it's 2 square root of 2. Okay, or you could also do radical jail. So if you were to break the square root of 8, you could get 4 and 2 and 2 and 2. So 2 times 2 times 2 times 2. You pair them up, one can escape jail, but one will die in the process, so it will be 2 square root of 2. Okay, this one, let's go ahead and subtract 10. So I get 4x squared is equal to 36. Divide by 4. So x squared is equal to 9. Square root both sides, so x is equal to plus or minus 3. Okay, let's go ahead and add 5. So 3x squared is equal to 30. Divide by 3. X squared is equal to 10. Square root both sides. X is equal to, right now, plus or minus 10. So let's go ahead and see if we can break 10. So if we're doing radical jail, that's 5 and 2. There are no pairs, so nothing would escape and nothing would die. So square root of 10 is the lowest it will go. Okay, this one we're going to add 10. Divide by 7. So x squared is equal to 5, square root both sides, x is equal to plus or minus the square root of 5. 5 cannot be broken down anymore, so we're going to leave it like that. Okay, now we're going to do something a little different. This time we have an x squared and an x in here, okay? On the last ones we just had x squared. So this time we can factor this left side. So what multiplies to get me 4 but adds to get me 4 is 2 and 2. So if I wrote it x plus 2 times x plus 2 is equal to a 25. Well, if I have the same thing written twice, I can rewrite it with a squared. To get rid of that squared, I could square root both sides. So once I square root it, the squared goes away. It doesn't affect anything underneath this radical because we're trying to get rid of that squared. So it becomes x plus 2 equals that plus or minus 5 because we're still solving. So x equals, we have to subtract 2, plus or minus 5 minus 2. So if we wanted to simplify, we could do our positive 5 minus 2 and our negative 5 minus 2. So we get negative 7 and we get 3. Okay, this one, it looks like there's an x squared and an x again, so we're going to have to factor. So it multiplies to get me positive 49, but adds to get me negative 14 is negative 7, negative 7. So if I wrote it x minus 7 times x, x minus 7 is equal to 25. That can be written as a squared because it's the same thing written twice. To get rid of that squared, we could square root both sides. So it will cancel that squared, so it will become x minus 7 is equal to plus or minus 5. We would add 7 to both sides. So x is equal to plus or minus 5 plus 7. Let's go ahead and break it. So x is equal to positive 5 plus 7, and x is equal to negative 5 plus 7. So then we got x is equal to 2, and x is equal to 12. Okay, so it multiplies to get me 9, adds to get me 6. We could do 3 and 3. So x plus 3 times x plus 3 is equal to 1. So x plus 3 squared equals 1. We square root both sides to get rid of the squared. So x plus 3 is equal to plus or minus 1. So x is equal, we subtract that 3 to both sides, to plus or minus 1 minus 3. So we're going to break it 1 with my positive 1 and 1 with my negative 1. So we get x is equal to negative 4 and x is equal to negative 2. So it'd be crossing that x-axis if I graph this at negative 2 and negative 4. Okay, this one, what value completes the square? So we're going to be talking about something completing the square. So to find the value that would make this a perfect square. So to complete the square, we're going to use this equation. B divided by 2 squared, not that negative. Whoop. B divided by 2 squared. So remember, it always goes A, then B, and we're trying to find the C that makes this a perfect square. So if I plug in that negative 10, negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So if I plugged in a positive 25 here, let's see if it makes it a perfect square. Well, what multiplies to give me positive 25 adds to get me negative 10. That's negative 5 and negative 5, which we could write as a perfect square. Okay, so completing the square, you're going to be using this equation. Okay, so this time my B is 18. So if I do my completing the square thing to find that back end number to make it a perfect square, 18 divided by 2 is 9. 9 squared is 81, so plus 81. So what multiplies to give me 81? But when I add it gets me 18, well 9 and 9, and that would make it a perfect square. Okay, this time my B is negative 1. So negative 1 divided by 2 squared is going to be negative 0.5 squared, which is going to get me 1/4. So I could add 1/4 onto this, and it will give me my perfect square. So that would be x minus 1/2 and x minus 1/2 if I factored it. Okay, so this time, this represents my B, so we have negative 12 divided by 2 squared, so negative 6 squared, which is 36. And the thing that's different about this one is that I have an A value, so I need to take whatever that is and divide it by 4 to get this. Okay, because remember when we send it back we normally multiply it, well this time we're dividing it because we have to have that A gone. So 36 divided by 4, we should get 9 here. So that's what's different about this one is that we have an A value that normally we would send back and then divide by, so we have to divide by it to get the C value that I want. Okay, so we have something in front here again, so when I do this I need to make sure I divide by it. So 10 divided by 2 squared, we got 5 squared, so 25. 25 divided by 25, okay, 1 is going to be the value in here that's going to make it a perfect square. Solve by completing the square. Okay, so this is a little different because on these ones we were trying to find the value that make it a perfect square. The other ones we had perfect squares. This one I don't have a perfect square yet. So I need to get it into a form that I can make that perfect square. So what we have to do is find the value that fits in here that will make it a perfect square. So what I'm going to do is I'm going to subtract this 6 over. So I get 3x squared minus 12x equals negative 6. Now let's find that value in here that's going to make it a perfect square. So I'm going to do my negative 12 divided by 2 squared, so negative 6 squared, so 36. We have an A value, so let's go ahead and divide that by that A value. So we're going to get that C value to be 12. So I need to make sure that we're adding 12 in here. But I can't just add 12 to one side and not to the other side. So when I add 12, I need to add it to both sides. So it becomes 3x squared minus 12x plus 12 is equal to negative 6 plus 12 is 6. Now let's go ahead and start factoring this. So let's send that 3 back. So what multiplies to get me 36 adds to get me negative 12 is negative 6 and negative 6. We can write that as a perfect square, which is why we did all that work. Getting rid of the squared, we have to square root. So I get x minus 6 is equal to plus or minus the square root of 6. We add 6 to both sides. So x is equal to plus or minus 6 plus 6. Plus or minus the square root of 6 plus 6. So if I wanted to write it with the separates, we could do a positive 6, and then we could do the negative square root of 6. Okay, we already have the 11 subtracted over, so we need to find the value in here that's going to make this a perfect square. So I'm going to take that b value, so 8 divided by 2 squared, so 4 squared gets me 16, so we're adding 16 to both sides to make it a perfect square over there, so we can complete the square. So x squared plus 8x plus 16 equals 11 plus 16 is 27. So what multiplies to give me 16 adds to give me 8. It's going to be 4 and 4. We can write it as a perfect square, so x plus 4 squared. To get rid of the squared, we can square root both sides. So x plus 4 is equal to plus or minus the square root of 27. 27 can be broken down further, so let's go ahead and do our radical jail. So we got 9 and 3 and 3 and 3. So we put them all in jail. We pair them up, one escapes, one dies, and then we have one left. So I have 3 square root of 3. So I got x plus 4 is equal to plus or minus 3 square root of 3. Then we can subtract this 4. So x equals plus or minus 3 square root of 3 minus 4. We break it with the plus and the minus. So x equals the positive 3 square root of 3 minus 4 and the negative 3 square root of 3 minus 4. So that would be where it's crossing your x-axis at.